Hello, this is Mr. Hodgen, and this is pre-calculus. This is going to be our first notes we do together, and it's important that you take notes, which doesn't just mean copying down what you see, but also engaging with the material. Meaning, if you have a question, you write that down as well. If you want to highlight, if you want to make any additional comments or notes to yourself of what something means because you want to put it in your own words, that's a good idea as well. The main goal here is that you understand the basics of what we're going to do the very next day in class, right? So you're going to have a quick, brief overview when you get to class, followed by a whole period of you working on problems based upon these notes. So you have to have already gone through these notes, watched the video, ask some questions to yourself, and make sure you're fully engaged, right? You are not doing anything else. You are not too sleepy, right? You have to be able to watch this video, write down everything, and then remember everything for the next class, right? Full engagement. All right, and if you do that, right, I promise you'll get any questions you didn't understand in this video answered at the beginning of class, and then you'll be ready to do the classwork assignment immediately and work on it for the entire period. All right, so let's get started with functions. You've heard of functions plenty of times, right? There's many different definitions for them. But basically with a function, right, if you're graphing a function, it says that it's a mathematical relationship that maps or connects a set of input values. Input values are the x-axis, or anything you plug into it, and the output values, which we traditionally have called y. You'll find moving forward, we kind of erase the y and we change it to a function name, such as f of x, right? So we plug in x, and the answer is now f of x, meaning the answer we got from this value. So if I plug in, let's say 2, f of 2 is the answer I got from 2. So that's why we use that notation, because this notation lets us know, well, where did this answer come from? Well, it came from the number we plug in there. Okay, but just think of f of x and y as the same thing for now. Right? Everything we look at that goes into the function is the domain. Right? So all these values on the x are called the domain, collectively, domain. So that's all the values of x that you could possibly use for any given problem. All of the outputs, right, are called the range. So anything that we get here as an answer is going to be in the range. Okay. And then we say that the outputs and the inputs vary in tandem, which means you plug in an input from the domain, x value, and you plug it into any function, right, and it'll just vary. It could do many, many things, right? So you're going to see a lot of different graphs that are not just straight lines or, perfect things. They're going to go all over the place, and that just means they vary in tandem. Meaning as an x changes in the domain, the f of x changes in the range, and they just vary together. They go up and down. Okay, what a function is not, right? Up here, I'm going to write this in green, right? Is that you have to have exactly one value for every input value. So any value I pick on the x-axis, let's say this is 6, it can only have one value on the y-axis or the f of x-axis. Right? We can't have both a value right here and up here off some other graph, like if we had two lines going or something like that. We'd have another value for 6. You can only have one. Now this hopefully makes sense. This is kind of like if you imagine like a real life case. Like for temperature or something like that, that means like at 6 o'clock, the temperature is whatever this is, right? We can't have another temperature over here. That means at 6 o'clock, it could be this hot and also this hot at the exact same time. So that's why we have this rule that there's only one output. So that way we know at this time of day, 6 o'clock, it can only be this exact temperature, and there's no possible other temperature that it could be. Right? So when we talk about real life problems, it becomes important to be working with a function as opposed to just some other graph. Okay? So that's just a few basic definitions and what a function is and domain and range. All right, so different ways to represent a function. We have 4 different ways we really look at, right? Graphically, numerically, algebraically, and then verbally. And they're all could be the same thing. So all these are actually 4 different representations of the same problem, right? So this table and this graph show the same information. And the words down here accurately describe what's on this graph, which is this table, right? If we went to Desmos and graph this, you would end up seeing this curve, right? So there are many different ways to look at information. Okay, so we can look at, let's say right here, says an input value. Remember, input or domain, that's the same as x. Now in this, we actually have t for time. So usually it's x or t. This time it's t, right? So you just go to 6, and then you find out its output value, which is right there, which looks about to be almost 70, right? This would be 70 right here, right? So pretty close, right? So I'm going to say my value here, okay, temperature at this time is equal to, well, say about 70. Right? We could also use a table, right? So here it actually gives us the function. Now this t, this big T is the temp, right? Right, that's what we got on the y-axis, temp, big T. And the little t here, of course, is time. So we're plugging time into a function that will give us an answer of the temperature. So whatever this big letter is or small letter is, right, that's the answer that you're looking for. So here you see a somewhat complicated function, right? It's a parabola because I can see, it's got degree 2. That's why it has this shape. But you notice how these have decimals. So you will need a calculator in this class, right? We have them hanging on the wall, right? But you'll definitely need a calculator, right? So I have mine right here, and I'm going to use this, plug it in, right? There's a couple ways of doing this, right? But I'm going to show you one. So first of all, we have to have more than just the basics, right? We need to have all these other buttons that you're going to get very used to. One of the very important things to start off with is that there's a difference between the subtraction button right here, right, and a negative button. So if you have a negative to start off your function, like right here, like this technically isn't subtraction, it's a negative. So we have to hit the negative at the beginning of a function if it has it there. Then we put 0.38, right, and we're going to plug in 0. So all I have to do is hit parentheses, 0, close the parentheses, and then take it to the second power. And there is a second power button on here. So I can just press this, and it puts it right there. And then just continue. So I'm going to do plus 9.4, parentheses, and 0. Open and close. And then lastly is add 28. So I'm going to do plus 28. And no surprise, it gives me an answer of 28, because 0 plus 0 is 28. Alright, so I got 28 here, and that should correspond to what we have over here. So if you look at 0, right, that's a little bit below 30, so that makes sense that that's 28 right there. And let's just keep going and do another. So now we're going to plug in 6. Now the cool thing about this calculator, I can just go back up here, and wherever there's a 0 in parentheses, I can just now scroll to it, right, like this, and hit 6. So try that. And then I'm going to scroll to the next one and hit 6 as well. All right, that way I don't have to retype the whole thing. So if I hit enter this time, it says 70.72. Right, and that's for 6. And that's what we did earlier, right? When I was looking at the graph, find the value of 6, it looked like about 70. Now I know, right, T of 6, or T, the temperature at 6 hours, that's what that means. What is the temperature at 6 hours? It's actually 70.72, which is, we had a very good estimation, but we could say this is equal. Well, before we could say it was approximately. It's just rounded. All right, one more time. Let's do plug in 12. So if we want to cheat a little bit, look at 12, and you can see, well, 12 looks like it's going to be a little bit above 80, some decimal, right? And that's one of the drawbacks of a graph. It only gives us approximation, whereas a function gives us the exact amount. All right, now we got to be careful on this. Okay, so we need to plug in 12, and I want to go back here, and I want to replace the 6 with 12. Well, if I just go to the 6 and hit 12, you notice it overwrites the parentheses. So I have to actually insert a new parenthesis there. So right above, you can see here at the very top, it says delete. But right above that says INS. That means insert. So since it's blue, I have to hit this blue button first, and that activates whatever the blue command is above the button. If I just hit the button, it does that. But if I want the blue part, I just have to hit the blue button before. So I'm going to hit second, insert, and you see the cursor changes, and I can put it in parentheses. And I'll have to do the same thing again over here, right? Because if I just go over to 6 and I put a 12, right, it removes the parentheses, so I hit second, insert, and then close the parenthesis. Right, and it gives me 86.08. There we go. So that's what this function equals at 12 hours. At 12 hours is about 86 degrees Fahrenheit. Okay, and it says, okay, so that's the table. And we go down here, if the input value is 12.5, right, so that's just a little bit above right here, so I could always use my calculator once again and do 12.5. Right, so the question here is like, what's my input value is 12.5, what is the output value? So it's asking, what is the temperature at time 12.5? Or at 2.5 hours. Or if we're thinking about, time of day, this would be at 12 o'clock and a half, which would be like at 12:30 p.m. And then once again, I'm just going to plug it into my function, right? So I can use my calculator. It's one of the cool things about pre-calculus is that you use a calculator a lot. So I just have to go back up here and change 12 into 12.5. Now I have to do insert again, right? So I have to go second, insert, and then add a 0.5. And then move over right here, go second, insert, 0.5. Now you might need to pause the video and do this a few times to make sure you can do it, right? Because remember, you want to come into class and actually know how to do these things and not begin, stuck too long on just the technology. All right, 86.125. Okay, so it went up just a little bit after a half hour, just went up a little bit more. All right, and lastly, we have the temperature for a city in Colorado is modeled by the function t, whereas t represents the hours of day, and t of t represents the temperature in degrees Fahrenheit at any time for the whole day, right? 0 to 24, right? This means 0 to 24 hours, 24 hours a day. Use the model to help predict the temperature at 6 p.m. Right, so 6 p.m. is going to be from 12 o'clock and then plus, high noon, plus 6 more hours. So we have to be careful and know that on the graph, even though it says 6 p.m., that's the same as 18. We're talking about the time. You might, if you know military time, you know that 6 p.m. is 1800 hours. All right, so we can do the same thing. We want to find t at 18. And then one more time, we can use our calculator. So I go back up. I'm going to change, see here, change this. Oh, there we go. I can change this to 18 hours and then just delete. So I'm going to hit the delete button. Deletes the decimal and the 5. Then I can go over here and do it again. I want 18 hours, so I'm going to do 18 and delete the decimal, hit delete, and delete again. So now we have a function we're plugging in 18, which is it's going to be about 74 degrees, 74.08. All right, and you notice on these answers, we're not really putting degree symbols, right? Because we know that this is a temperature, right? That's what it stands for. We can do that if we want. It's not required on most of these, right? It's kind of understood that's part of the problem. But just so you know that what your answers actually mean, you can go ahead and put it, right? And we could put time and we could put hours, right? Because that's what it says it is right there. So we could gone through and said, okay, this is hours. Or you could just abbreviate it and put HR if you want. Okay, so just know that there are units connected to these. So that's just the basics. We're going to be looking at a lot of these types of different representations of all our families of graph that we've been looking at. All right, let's go to the next page. Look at something quite different. So a lot of things you'll find in pre-calculus, you already know what they are. We're just going to call them a different name. Okay, so whereas in previous classes you might say, well, where is the graph above the x-axis? Right? Where is it above the x-axis? Like that. Well, that's going to be where, instead, we're going to call that, where is it positive? Or more specifically, where is f or y? Where is the y-axis positive? So you can see that would be all this. This is where it's positive, above the x-axis. Right? So if I'm asked, where is state the interval where g is positive, right? And this function is g right here. Everything on here, right? This is g. Where is it positive? It's just saying, well, what numbers on the x-axis is it above the x-axis? Right? So it says intervals. Now, this stands for interval notation. So you're going to write all your answers in the interval notation. It means you use parentheses on the other side. You might have brackets on both sides. You might have one bracket and one parenthesis. It just depends. Okay? So they're saying, where is it above the x-axis? All right, so for this one, we can see wherever it's highlighted, right? Or that's where it's going to be positive. So from here all the way to here. Now we're looking at the x values, right? So from -4, and this is 0. So I'm going to say from -4 to 0, it's positive. Now we can also see this is highlighted, this is 5, and this is 6. So also from 5 to 6. So from 5 to 6 as well. And then we can see up here. Now this is also 6, right? So it keeps going from 6 to this number 9. So we could write this again like 6 and 9, but really these have the same values right here, this 6 and this 6. So it really keeps on going from 5 and then all the way to 9. So we're going to say instead from 5 to 9. We're going to combine these together and just say from 5 to 9. Right? All right, and if we use these arrows down here, you might see these arrows, in all our graphs. That means it keeps on going forever. So it means that we're going to, well, actually, let's not worry about that yet. That's going to come later. But one thing I did want to say is that when we have multiple parts of the graph here that are positive, and we want to say, well, these are together, we put this U between them, and that U stands for union. Just means both of them together. So when we have different parts or different intervals in our answer, we usually put this U between them. Say it's all the values of x from -4 to 0, and all the values from 5 to 9. All right. So now let's do the same thing, but where it's negative. All right, where is it negative? So we're going to go over here. And that's going to be everything. I'm going to be a little more careful here. Nope. Yeah. There we go. Below the x-axis. Right, so where is it below the x-axis? So we have this part right here. That's below. We have all of this. That's below as well. Okay. So where is it negative? Now, I was mentioning this arrow here earlier. So what does this arrow mean? It means it goes forever. So really, we could say that on the far left, there is also negative infinity. On the far right, there's also positive infinity. That's always going to be there. That's what these arrows at the end of the axes mean. So you might say, well, it's everything less than negative 4, but in interval notation, the way we write that is say, well, it's from negative infinity to 4. Right? And then over here, looks like it starts around, let's see here, 9. Right? It's negative from 9 to positive infinity. Right? And then we go ahead and put the union between them as well. All right, going on, now we have the zeros. We have the zeros. So we talked about where it's negative, below the x-axis. Now we got to talk about the zeros. Right? So a graph function will intersect the x-axis. That means the output, or the y value, is 0. Right? And we call those the zeros. So every time you hear zeros, you're thinking about anything that's happening right here, where it actually intersects the x-axis. So these are going to be values. Right? So what are the zeros? Where does it actually cross? So that would be right here at negative 4, at 0, x equals 0, at x equals 5, and at x equals 9. You can say x equals, and it's a set of numbers, so I'm going to put it in a set, which is a curly bracket. So I have negative 4 is the first one, then 0, and then 5, and then 9. All right. So 3 important things. Where is it positive? Where is it negative? Above the x-axis, below. And what are the zeros? Where does it actually equal 0? So you can imagine we covered positive numbers, negative numbers, and then where it's actually 0, right in between them. All right, good. Okay, the next part is, where does it increase and decrease? Okay, now there's some language here that's very technical, right? Here, right, it says if A is less than B, then f of A is less than f of B. Right, this is just a fancy way of saying it's going up, it's increasing. You don't need to memorize this, but this is just some definitions that you're going to see along the way. But increasing just means does it go up? Right? And decreasing just means does it go down? Is it going downward? Constant means not up or down, right? It's just going to stay straight. So a graph, right here, you can see, is increasing, and now it's decreasing. This is decreasing, now it increases, and now it's decreasing. So it's just going up and down, up and down. Okay? So when we're looking at this, it says consider this function, and it says use green, so just use the, if you have a highlighter or something like that, that'd be good. It says use green, identify the intervals once again, where it's increasing. So you look at this from left to right, right? Very important, from left to right. So I got to start here, and you can see I'm going down, 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 and then increases from here to here. So you're always reporting the x values here, okay, the x values. So you're looking at from here, that's 0, and then to 2, it's increasing. So from 0 to 2, that's where it's increasing. And we use parentheses again for interval notation. We don't include 0 or include 2, by the way, because that technically at 2 or at 0, it's not increasing or decreasing. Right when we hit this point, it's not going anywhere. And then when we go a little bit above 0, that's when it starts increasing. And then now decreasing. We're going to do red. So of course this is going to be right here. This decreases. Remember, we have another number over here that's negative infinity. So from negative infinity to 0, right, that's where it's decreasing. And then also over here, Right, so starting at 5 and going to positive infinity. Because this goes down forever and ever and ever, right? It just keeps on going. So, so right here, from 5 to positive infinity. Again, we use a union to link the two parts of the answer together. All right, lastly, we're going to do constant, which means straight. So we're just going to go from here to here. That's constant, not going up, not going down. So that's from 2 to 5. So from 2 to 5. Yellow, and I'm going to overlap that with some black and yellow so we can actually see it. Okay. All right. So increasing, decreasing, and constant. So we're just talking about all the different parts of the graph. Like we did positive, negative, and now we did increasing and decreasing. Or neither, which is called constant. Right? Constant is the absence of something increasing or decreasing. All right. Lastly, let's look at functions. Exactly what are they? There's something called a vertical line test that we can use for functions. Right? That lets us know if it's a if it's one-to-one. I kind of touched on that earlier over here. Right? So if I included this line, this dot right here in my earlier example, if I draw a vertical line, you'll notice that it goes through both of these. So if a vertical line goes through 2 points on the y, that means it's not a function. It can only go through 1 point. So if this wasn't here, and I do draw a vertical line, it only hits this orange graph at 1 point. So that means it is a function. So that's what they call the vertical line test. Right, but there's other ways of looking at functions, right? They could just be a list of coordinates. Right? We can have this mapping diagram. That's what that's called. And basically you're just looking for, right, if there are 2 x's with the same y. So you can see we have x's of 7 here. Make this a little bit bigger. Uh-oh. Yeah, there we go. Right, so this x has this y, right? 7 has a y, negative 3 has its own y, 1 has its own y, 3 has its own y, and 2 has its own y. And that might just seem very general. Just think about this as the temperature. Like at 7 o'clock, it has a temperature. At negative 3 o'clock, if that's a thing, it has a temperature. At 1 o'clock, it has a temperature. At 3 o'clock, it has a temperature. At 2 o'clock, it has a temperature. The main thing is that none of these repeated. We didn't get the same x value and 2 different y values. That's what's important here. Okay, so on this one, we could say, yes, this is a function, right? And they say write out the domain and write out the range. So let's do that too. So my domain, remember, is just all the x values. Right, so domain is going to be curly bracket. There we go. I'll just write them in the same order. 7, negative 3, 1, 3, and 2. Just listing everything. That's the next coordinate. And then we could do the ranges. Right, of course, that's going to be these ones. So we have range. Negative 2. And 5. And 6. And negative 4. And 5. Good. All right, now it says justify if it's a function or not. I'm going to say yes, it is a function. Right, this is a function. Right? And we say just use the definition of a function. Each x maps to 1y. And you just use this answer generically all the time. If the answer is yes, this is the reason. Each x maps to to 1y. Right, and we can look at, okay, so that's good. And we can look at this next one, which is called a mapping. And we could write these out as coordinates. It's a little bit different here. But you can see like negative 6 maps to negative 4. That's the same thing as negative 6 maps to negative 4. So that's a coordinate. And we can just keep this going. -3 maps to 0. Okay. Then we have 2 maps to 0. All right. And then also we have 2 also maps to -2. And the last one here is 3 maps to -1. All right. Now we have a problem here, right? This is not going to be a function. No. Why not? Remember, think about this as time, or time of day. Like at -6, let's say 6 hours ago was -4 degrees. At 3 hours ago, right, it was 0 degrees. And 2 hours from now, it's 0 degrees, which is fine. 3 hours ago, it was 0 degrees, and 2 hours from now, it's also 0 degrees. That's fine. But then right here it says, oh, 2 hours from now, it's -2. So we now have this mapping telling us, hey, in 2 hours, it's going to be 0 degrees. Also, in 2 hours, it's going to be -2. That doesn't make sense. It can't be 2 different temperatures 2 hours from now, right? So therefore, it's not a function, right? You can say, in this case, we could be particular. We could say x equals 2 maps to 2 values. Right? And that does not make sense. Right? We can't have word problems or real-life problems doing this, where you're measuring something and it's 2 different temperatures at the same time. Okay, so that's domain and range, and if is a function or not a function. All right. Let's move on down. Talk about this. Okay. Example 4 says, sketch a graph of a function increasing or decreasing, right? So the graph of g is negative and increasing. Okay, graph of g is negative and increasing. So it's combining the positive negative and the increasing decreasing from before. All right, so negative, what does that mean? Right, if you need to, you can always go back. Right, negative, below x-axis. So we need to be below the x-axis, our graph, and it needs to be increasing. So it needs to be going up, but stay below the x-axis. So it just combines these 2 concepts into one. And there's no right single answer here. So you could draw anything. I'm going to draw something like this. How about something like that? Right? So this is both negative and increasing. It's staying below the x-axis, but still going upwards. But it never goes above the x-axis. So you see my arrow, it just kind of keeps on going this way and stays below. But you could draw many different graphs. That's just one of them. This one says positive and decreasing. So I'm going to do I'm going to do something like this. Right. So this is positive above the x-axis, and it's decreasing, right? From left to right, it's going down. I put arrows on both sides and mean it keeps going forward. All right, so that's going to be the end of the notes for the first day. Right? We did a couple concepts, and anything you didn't understand, you want to go back and look at it. You want to go back and make sure if you have any questions, get them answered. You could always look things up online if you need to, because you're at home, right? If you didn't like these mapping questions, you could look up, function or not a function with a mapping, right? And you can get more examples, or you could just write a question down and bring it to class the next day. All right, so that will be it for this video.